name is Masanga. In this video, I'm going to discuss about linear algebra. Linear algebra is a branch of mathematics that is concerned with mathematical structures closed under the operations of addition and scalar multiplication that includes the theory of systems of linear equations, matrices, determinants, vector spaces, and linear transformations. History of algebra. Muhammad was a 9th century Muslim mathematics and astronomer. He is known as the father of algebra, the word derived from the title of his book. His pioneering work offered practical answers for land distribution, rules on inheritance, and distributing salaries. Algebra. In mathematics, algebra is a branch that deals with symbols, variables, numbers, and rules for manipulating it. It states the mathematical relationships that are used to find the unknown value by creating expressions and equations. Mathematical equations. An equation is written as two expressions connected by equals sign. The expressions on the two sides of the equal sign are called the left-hand side and right-hand side of the equation. Very often, the right-hand side of an equation is assumed to be 0. This does not reduce the generality, as this can be realized by subtracting the right-hand side from both sides. A variable is a letter representing some unknown. A variable always represents a number, but it carries varying values. But when written in an expression, by convention, mathematicians usually assign letters at the end of an alphabet, such as X, Y, Z, to be variables. Then what are X and Y? These are varying quantities because you can substitute different values for these, and therefore they are called variable. What is a constant in mathematical equation? A constant is a term that What is a constant in mathematical equation? A constant is a term with a fixed value in an equation that is not affected by any changes in the variable. For example, here the constants are 3 and 4. What is a coefficient? A coefficient is a factor that multiplies the variable. It is often a number but can also be an expression. The terms coefficient and constant sometimes are used interchangeably, particularly as parts of a function, as a constant can be considered a coefficient where it multiplies the variable raised to the 0th power. For example, 5x to the power 0 is equal to 5. Relationship between linear algebra and informatics. Computer graphics. Linear algebra is essential for representing and manipulating images, shapes, and transformations in computer graphics. Concepts such as vectors, matrices, and transformations and projections are used extensively to model and render 3D scenes, simulate animations, and perform image processing tasks. Machine learning. Linear algebra provides the mathematical foundation for many machine learning algorithms. Techniques like linear regression, logistic regression support vector machines and principal components analysis. Rely heavily on matrix operations such as matrix multiplication, inversion, and decomposition. Cryptography. Linear algebra is used in various cryptographic algorithms or encryption, decryption, and key generation. Public key crypto systems such as RSA and elliptic curve cryptography are based on mathematical structures like vector spaces and finite fields, which are studied in linear algebra. Data analysis and data mining. Linear algebra is used to process and analyze large data sets in data science and data mining applications. Techniques like singular data decomposition, eigenvalue decomposition, and matrix factorization are employed for dimensionality reduction, clustering, and feature extraction. Optimization. Linear algebra. At the core of optimization, algorithms used to solve various optimization problems in informatics. Techniques like gradient descent, Newton's method, and linear programming rely on matrix calculus and algebraic operations to find optimal solutions. Network analysis. In network analysis, a graph theory, linear algebra, is used to study the properties of graphs and networks. Graph adjacency matrix, Laplacian matrices, and spectrograph theory are techniques used to analyze connectivity, centrality, and clustering in networks. Thank you for your attention.